characteristics of rocks. Though rocks constitute a very solid mass, certain rocks have very tiny spaces within it, which are called pores or pore spaces. The reservoir rocks, which contain hydrocarbons, have pores within it. Oil and gases are present in the pores of these rocks. Larger pores imply a higher porosity of the rocks. Another feature of the rock, which is desirable for drilling oil, is its permeability. A rock is permeable if its pores are connected. This allows the oil to flow from one pore to another. Thus, a higher porosity and permeability of the rocks provide a favorable situation to drill oil. Origin of oil. Oil is found in porous rocks. But how did it originate and get there? One of the widely accepted theory for the origin of oil is the organic theory. According to the theory, the remains of an abundant plant and animal life in the ecologic past slowly got buried in the ocean floor. Along with organic remains, the rivers that flowed to the seas deposited large amounts of silt and mud. The dead organisms, along with the silt, sand, and mud, formed a rich organic mixture, cut away from oxygen, thus not decaying in the normal way. Huge repeated deposits above this organic mixture resulted in tremendous pressure to act on it, thus converting it into rocks. Heat, pressure, bacterial and chemical reaction, and other factors resulted in the organic remains to be converted to oil and gas. Continuous squeezing of the source rocks resulted in a primary migration of oil and gas into adjoining porous and permeable sedimentary rocks. Reservoir traps. The oil as we find them today occur in different arrangements of rocks, referred to as traps. While oil and gas were formed, forces of nature, like earthquakes, shifted blocks of earth in various directions. The pressure from the various forces resulted in the secondary migration of oil and gas towards the Earth's surface. Along its path, oil and gas were blocked due to different types of impermeable rock formations, thus trapping the hydrocarbons in sedimentary porous rocks. The sedimentary rock that contains the hydrocarbons is called a reservoir. The traps may be of various types depending on its formation. Factors that resulted in the formation of the traps include folding, faulting, unconformities, domes, and plugs, etc., and their combinations. Based on their formation, common types of traps found are anticlines, faults, unconformities, and domes and plugs. Anticlines. As shown in figure, anticlinal traps arise due to folding of horizontally laid down rock layers. Oil and gas, which have migrated into porous rock in the anticline, is sealed by an impermeable layer above it. Fault. Fault traps are those formed by breaking or shearing and offsetting of strata. The example shows a formation where layers on one side of a fault have moved in relation to the layers on the other side. Hydrocarbons, which have migrated into a porous sedimentary layer on one side of a fault, are sealed by an impermeable layer on the opposite side. Unconformity. In these traps, the upward movement of oil is blocked by an impermeable caprock laid down across weathered surfaces of the lower beds. The formation shown above could have developed due to an initial deposit of layers on the seabed, which stopped due to some reason, like the sea having retreated. Later the layers were tilted by earth movements. The area exposed was then subjected to weathering by erosive forces. After a period of time, changes occurred, which further deposited new layers above the weathered ones, resulting in this type of formation. Dome and plug traps. Oil accumulations are found in porous formations, on or surrounding impermeable domes or plugs of material, usually salt, that have pierced, deformed, or lifted the overlying rock layers. Reservoir fluid composition. Before the oil and gas that migrated into the traps, the rock pores actually contained salt water. This salt water was displaced by the migrating hydrocarbons. The oil, gas, and water are found segregated vertically because of the differences in their density. Gas, which weighs the least, is found at the top, followed by oil, and finally salt water at the bottom because it is the heaviest of the three. However, the entire water is not displaced in this manner, and around 10 to 50% water may still exist in the pore spaces. This water is called connate water. It may exist in the smaller pores and coat or form a thin film around the grain rocks surrounding the larger pores, which contain the hydrocarbons,